So now we are very excited to introduce Pratik Patel, a Java champion and developer advocate at Azul Systems, known for his authorship of 3 books on programming covering Java, Cloud, and OSS. Today, Pratik will delve into the topic of serverless and cloud function architecture. Pratik, the stage is yours.
There we go. Good afternoon, everyone. See, let's try that again. Good afternoon, everyone. Thank you. All right, so thanks for the introduction. My name is Pratik Patel. I'm Java champion based out of Atlanta, Georgia. Does anyone know where Atlanta is in the US? Okay, so that's almost nobody. So Atlanta is in the southeast US. It's the largest city in the southeast. And I help lead the Atlanta Java user group there, among other things. But as she said, I've written a few books, including on cloud, and that's what we're here to talk about. And also, more importantly, for this specific event, I was a lead architect at Deutsche Bank in London and a lead architect at AT&T in Atlanta. So I've had a little bit of experience doing large-scale architecture, which I hope to impart on some of you in this specific presentation. The company I work for is called Azul Systems. What we do is we build Java virtual machines. How many people are Java developers in here? All right, so how many people are not Java developers? Let's try that. Oh, wow, okay. So for those of you who aren't Java devs, what do you build in? Just shout some out, like you. What's that? Python, what else? C++, okay. That one person who does C++ here. Anybody doing JavaScript? Okay, a few people doing JavaScript, okay, that's great. So the reason why I asked that question was because this specific session is about architecture around all of those different things, whether it's C++, Go, Python, JavaScript. And Nate still writes in OCaml, right, Nate? Is that right? He's not listening. Yeah, he does. Okay. Anyone use OCaml out of curiosity? No? Okay, that's a little esoteric. So anyways, for those of you who are Java devs, something I'll talk very briefly about in this session is something called CRAC, or Fast Startup for Java, that doesn't use GraalVM. So for the Java devs in the room, you know what I mean. But anyways, how many people have deployed stuff to AWS Lambda, Google Cloud Functions, or to Azure Functions in production? Let's have a look. Okay, that's pretty good. That's about 20% of the folks here. So I apologize to you in advance. The first 10 minutes of this will be very boring, but for everybody else, I hope you find it useful. So we'll talk about the architecture. We'll talk about the way that I approach this and what most people approach Cloud Function building with, or building applications with Cloud Function using an event-driven environment. And then we'll get into some tips to close this out, to give you an idea of what some of the best practices are around this. So I used to lead the Java and Cloud DevRel team at IBM, and we had our own IBM Cloud, which was based on an open source platform called OpenWhisk. Has anyone heard of OpenWhisk out of curiosity? Okay, a few people, good. It's actually an open source cloud function platform that you can actually run on your laptop if you have like 64 gigs of RAM. So, all right. So let's talk about serverless for a few minutes and get into, we already asked this question, so I'll skip it. I already asked who's building on which different platforms. We'll skip this for now, so it seems like there's a fair number of folks doing this, right? How many people are running stuff on Lambda? Okay, that's a lot of people. How about Google Cloud Functions? Okay, just a few people. Azure Cloud Functions? Okay, interesting. So there's, of course, everyone, the majority of the folks, by show of hands, I'd say about 60 or 70% of the folks were running on AWS Lambda. So we'll talk about those 3 platforms in a little bit of detail, but not too much. Okay, just to give you an idea of what the differences are if you're interested in them. Right, so what's the point in developing in a serverless style fashion? Right, so again, this is kind of elementary and basic, but this is where I like to start. So for most developers, when we think of Cloud Functions, we want it to be easier, and then also, if you care about money, how many people care about money? Okay, I'm joking, of course. Everyone cares about money, right? How many times have you gone to your manager and said, hey, I want $3 million to build this project? What's their first answer? First answer is no, absolutely not, right? They want a justification. So we all care about money as developers at the end of the day, because we have to build projects within a certain budget. We don't have an infinite amount of compute power and an infinite amount of manpower to be able to build things. So that's why we care about the cheaper part. And this is where Cloud Functions come in. It allows us to prototype and take something to production very quickly and at low cost without provisioning a large number of servers. Because everyone in this room is aware how expensive it is to actually run on the cloud, right? It's not cheap. And Cloud Functions are probably the cheapest option for running on the cloud today. Okay? So I'm going to use a couple of terms interchangeably. So for those of you who are already doing this, you're probably familiar with this first term, which is functions as a service, also known as Cloud Functions. It's not the same thing as serverless, though. We'll talk about serverless in just a minute to give you an idea of what the serverless umbrella is and where Cloud Functions fit into that picture. All right? So when I think of application development, I think of this pyramid. Right? So at the bottom, we have just base infrastructure. This is bare metal. And then on top of that, you have some kind of platform, whether it's Linux or, I don't know, maybe you're running on some kind of service mesh. And then nowadays, everyone builds with containers. And we build apps out of these containers, and we weave them together. Okay? So how many people don't use Docker today, out of curiosity? How many people are deploying straight onto bare metal? Anybody? Okay, one unlucky person. So do you name your servers like, you know, never mind. So remember when you used to do that? You would actually name your servers like, you know, the different rivers of the earth or something like that. But we don't do that now because a long time ago we figured out that it was uneconomical to do that. So now servers have a very boring name with some kind of hash code or something. But anyways, you get the idea. Now, where does Cloud Functions and Functions as a Service fit into this platform? Okay, so there may be Docker containers underneath the hood. So for example, if you build on Google Cloud Functions, what happens is when you give it your code, it takes that and it produces a container, and then it essentially runs it on Google Cloud Run with some extra stuff around it. Is that right? You build on GCP, so you know, right? So this is the way I look at it. What we're doing is we're inserting something near the top of our stack, right underneath our application. This is how we weave together different Cloud Functions to build applications, okay? But I also like to think of containers as a service as kind of in the Cloud Functions family. Okay? So containers as a service, if you're not familiar with it, is you say, here's a container with my application, go and run it. And that's what it does. It goes and runs it. It scales it up and scales it down for you. So if you're not familiar with the specific products, for example, AWS has Fargate. Google Cloud has Cloud Run, is that right? And then Azure has Azure Containers. So these containers as a service platforms are very similar to the Cloud Function platforms that we're going to talk about today. But I group them in the same category. But for me, most importantly, when I'm building with Cloud Functions, the infrastructure is somebody else's job. As an app developer, the last thing I want to do is worry about all the infrastructure underneath and managing everything, okay? So how many people deploy on Kubernetes in production? Okay, right. So Kubernetes is a great platform, and unfortunately this session is being recorded, so I can't tell you what I really think about Kubernetes, okay? But find me during the happy hour and be happy to go on a long rant about it. I think Kubernetes is a great platform, but I think too many people use it for problems that they don't have. Does that make sense? Right? It's a sledgehammer, and then all of a sudden you have this 15-person Kubernetes management team that's all their job is to manage your Kubernetes instead of focusing on building your application. But again, we'll go on that rant over a beer or something later, okay? I'm sorry, this is Barcelona, so sangria, right? So the idea behind Cloud Functions, again, is that you can run code without provisioning or managing servers. And as a software developer, this is my dream. I can just write code, I can have the business analysts come and shout at me and say they need something, I write some code and I deploy and I don't have to worry about anything else, right? This is the dream that we want to live as application developers. We don't want to worry about all this operational stuff. There has been this movement, well, one thing I want to add in here, the way that Cloud Functions work is they typically use some kind of usage-based pricing, right? So these numbers I just made up, kind of. So you pay for like CPU slices times the amount of memory times some very, very small fraction of currency, and that's how much it costs to execute that Cloud Function, right? So this is the dynamic pricing part of Cloud Functions. You pay for exactly what you use, and the platform manages how many instances of your Cloud Function are live, so it auto-scales up and auto-scales down on demand. Hence, you get this very elastic and very flexible billing around this. Okay, so the other way I like to think about, how many people do DevOps in here? Okay, so it's quite a few people, and if you start moving to Cloud Functions, you may want to start looking to do something else, okay? Because for me, Cloud Functions and containers as a service should handle all the infrastructure for you. So I like to think of Cloud Functions as all of the dev with none of the DevOps, okay? Of course, that's not 100% true, but it would be nice if it were true, right? Because then you don't have to worry about all these low-level things. Now, if we take a step back from just cloud functions and we think about what is this overall serverless umbrella, right? So the idea behind serverless is that it takes care of the scalability and the availability and all the other things around us, hopefully including security. Maybe not for your application, but you don't have to worry about, oh, I'm running on this specific version of Alpine Linux that needs these security patches, blah, 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 right? Somebody else takes care of that stuff for you. And that's what we want. We want to focus on building our applications and not so much on the infrastructure and all the ancillary things around it. All right, so what else fits under the serverless umbrella? Okay, so there are things like databases, and these are mostly AWS examples, but Google Cloud Platform and Azure all have similar things. So for example, for serverless databases, i.e. databases which scale up by themselves and you pay per usage, something like DynamoDB on AWS or Aurora, and for those of you, for example, running on Azure, they have Cosmos DB, which is also available in a serverless-style billing and deployment model, where you just pay every time you make a query, depending on how long it takes for that query to run, you pay for that exact thing. Anytime you do insert, how much storage you're using, you pay for the exact amount of storage, et cetera, et cetera. So you're not standing up a database server and you're paying, whatever, $5,000 a month for it, and that's how much you pay. It's dynamic billing, okay? So similarly, on AWS, you have event buses like SQS and SNS, and there are other things which are charged in the serverless way also. For example, API gateway. Almost every API gateway deployment that you get on these cloud platforms is charged by the request, right? It's a very, very small amount of money per request, but of course, it adds up over time, okay? How many, out of curiosity, how many people are using a serverless database, like DynamoDB? Okay, that's actually quite a few, that's great. Now, the problem with all this, and we'll talk about this a little bit more in a minute, the problem with using something like a serverless database is that it's very easy to spend more on a serverless-style database deployment than just starting up your own database, or just picking from the cloud provider's database and say, I need this database cluster, and this is a fixed-size database, and I'm always going to be using it. So there's a line that you cross where it's actually more expensive to run serverless-style databases or cloud functions than it is just to have, you paying $5,000 or $10,000 a month for this, these 5 containers running your application, your database, and all this other stuff. Okay, so this is what we have to be careful of because no one wants to get a bill at the end of the month where you get a lot more usage than normal, and all of a sudden you're paying double what you might if you just deployed a standard database configuration into your application. All right, so let's talk about the architecture. We've covered all the serverless fundamentals. If you have questions, of course, we'll take them at the end. But this is where, as a software developer, with my software architect hat on, I think about how I have to build an application differently than if I'm just building a monolith or even a microlith. So I like to think of this thing as everything we do is on a spectrum, from very, very large monoliths to very, very small cloud functions or nano services, okay? So everyone has probably built a monolith in this room, right? Right, yeah, of course. Right, so how many people are building microservices right now? Right there. Okay, so that's about 70% of the audience. And I already asked how many people are building cloud functions and functions as a service. But the important part here is that when you're building in a monolith, or even in a microservice for that matter, what you're doing when you build a real-world application is that you're doing composition by code, as opposed to composition by service, okay? So what that means is, say that you want to integrate Apache Kafka into your application, right? Someone in management said, hey, everybody's using Kafka, why aren't we? And then all of a sudden you're using Kafka, right? So, so now you have to integrate this into your application. How do you integrate that into your app? Well, you go get the Kafka jar file or Kafka library for your platform, you mix it into your monolith, and then you make calls into the Kafka infrastructure, the underlying Kafka infrastructure, by directly calling code, right? When we think about this in terms of more nano services or cloud functions, what we do is we want to consume a Kafka service, and we do configuration rather than going and doing straight coding. Basically, what we're doing is consuming a service rather than consuming the Kafka libraries at a low level, right? So let me give you a concrete example of this, right, to help you understand, right? So when we're building a monolith, we do composition by code, right, and that looks something like this. And when, unfortunately, there wasn't enough room for the configuration here, but hopefully this gets the message across. In terms of thinking about this from both a software development perspective as well as an architect perspective, this is what the difference visually is to me. Right, so on the left, you can see that I'm using, this is actually the Spring Kafka template. For those of you who are Java devs, you probably recognize this. But what I'm doing is I'm integrating at the code level. I'm doing integration to use this specific thing. I pull in the library, I call the code, and that's how I start using Kafka, right? And it doesn't have to be Kafka. It could be anything. It could be LDAP, or connecting to a database and making queries, et cetera, et cetera. It could be any kind of service that you're using. Okay? But when we think of composition by service, we think in smaller chunks, and we think of things which are external to our system. So in this case, when I'm deploying something out onto AWS Lambda, I set up my Lambda. It's going to go and read from a Kafka topic and do some processing with that. But the way that I glue those two together is I have some configuration that says, go and implement this Kafka sync configuration, or this Kafka sync connector, sorry, with this specific configuration, and go and consume off of it. So I'm not integrating down at the code level. I'm not thinking like a developer. I'm thinking much more like a high-level architect, right? So this is one of the key differences that I feel that software developers and architects need to understand when they want to jump and use cloud functions. All right, so cloud functions, several years ago at least, felt like they were revolutionary. Like I can just give it like some code, whether it's in a binary or jar file or NPM package or whatever, and it goes and runs it for me. And it almost feels revolutionary in some ways, that, wow, I can do all this stuff and someone takes care of all this coding or all this infrastructure for me. But to be honest with you, where we're at today in terms of how we use compute, whether it's cloud functions or Kubernetes or whatever, all this stuff is evolutionary and not revolutionary. We built on years, decades, in terms of the way that we think about systems. So I was talking to some friends the other day that I used to work with at IBM, and they were reminiscing about AS400 mainframes. Does anyone have the guilty? Well, okay, so one person has done that, right? So if for those of you who don't know, there are these gigantic mainframes that you pay IBM lots of money for, but they could actually run multiple different applications within this giant piece of hardware, okay? And that was 30 or 40 years ago that style of computing was done. And today, when we think about the cloud, it's almost like that same black box, right? You just say, here's my stuff, go run it somewhere. I don't own the machine. I don't know where the machine is. And then if we think from an architect perspective, the way that we use event systems now, we were using event-based models many, many years ago. So for those of you who are Java devs, for example, we used to use Java Message Service, or JMS, right? Or maybe use RabbitMQ if you're building with Python or JavaScript. So these message buses or event-driven systems have actually been around for a long time. We're just building our understanding of what's the best way to build these larger scale systems, and we keep building on top of it. So the point of this slide is that everything we do today is not revolutionary, it's evolutionary. It builds on everything that we've done in the past as an industry, and as, just even for yourself, as your software career, right? How many people started building software with things like Visual Basic or Power Builder and Delphi, right? Right, so there's lots of those folks in the room, and you know that when you see something new, a lot of times it's like, oh yeah, I used to do that in Power Builder 20 years ago, or whatever your platform was back then. So we just keep changing the names of the way we do things, and that's how Nate makes a paycheck, so. All right, so let's get into some of the kind of tips and tricks that I use when I'm building cloud function-based applications to try to build them the right way up front, right? Software development, as you know, is an iterative process. So you build something, you write some tests for it. Everyone writes tests in this room, right? Okay. I'm actually going to print a T-shirt next time I'm giving a presentation that says, I don't normally test, but when I do test, I test in production. Exactly. So maybe it'll get some giggles. We'll see. All right? So keep it simple, stupid. This applies for everything in software development, obviously, but specifically for cloud functions, I think it's much more important to keep things as simple as possible. Right? Let's look at why. So first of all, when you're building cloud functions, the thing that I've seen with customers in the past is that they make their cloud functions too big. So here's a question for you, especially for those of you who already build stuff using cloud functions specifically. Say you're building an adapter down into your data store or database level, okay? Now, you need to do 4 operations: create, update, delete, right? 4 basic CRUD operations. Now, do you put those 4 operations into a single cloud function to access the data store, or do you create 4 cloud functions to do that? Okay, so why am I giving this presentation? Everyone knows the answers already, right? But what's that, 3? Okay, so, but that's absolutely right. So it's tempting to group those 4 operations which access a data store or database into one cloud function, because in your brain you think, well, those are all the same logical thing. Hitting a database, I want to simplify things by putting everything into one place. But the problem that causes in a cloud function, especially in a cloud function environment, is that if you put all 4 things into a single cloud function, then what you have to do is you have to send down a parameter that says, am I doing a create, or am I doing an update, am I doing a delete, etc., right? So what you're doing then is you're adding additional complexity that you then as a developer or your dev team have to go and keep track of, and it makes your overall system more complicated. So this is what I mean by keeping it simple. By having 4 discrete cloud functions that do all those operations, now you have Lego blocks that you can snap in anywhere without having to worry about providing additional context. It's that additional context that you have to provide that causes problems, because now you have to remember this, as opposed to just remembering, oh, this is the cloud function that goes and updates a record. Okay? And similarly, keep things simple, single purpose as much as possible. Right? So another key mistake that people make is that they do too much processing in a cloud function. A cloud function should execute in a short amount of time. If you're doing a large amount of computation or anything in a cloud function, you're basically doing it wrong, okay? And the second bullet here is the hardest. Cloud functions should optimally be stateless. Okay, so let me ask you a question. If you're building an application that has absolutely no state, what have you built? Exactly, you built nothing, because at some point you have to have state, right? Something has to go into a database eventually, or whatever, data grid. Now, you might be thinking, well, okay, let's back up for a second. Let's think of your standard web application. User comes in, they log into your web app, they put something into a shopping cart or whatever, okay? What you're doing is you're creating state at that point. You're creating the user's login, whatever stuff they have in their shopping cart, et cetera, et cetera. And the way that we do this architecturally today, if we don't think of cloud functions, is we have something called sticky sessions, right? So every call will go back to that specific instance of that where that user state is stored. So their shopping cart, their login info, their profile, et cetera. So let's say you have 10 different nodes in your application running, you're doing horizontal scaling. Every request from that specific user goes to this node. If that node goes down, the state is lost, the user has to log in, et cetera, right? But we know how to deal with that, right? But what we're doing is we're keeping state inside of memory, inside of a process on a specific application node, right? And what that does is that creates 2 bottlenecks, right? First of all, you have to route everything to that one specific thing. It creates a single point of failure, but you're also consuming memory. Right, user state you have to keep it somewhere, and typically it's kept in memory. So that begs the question then, if you want your cloud function to be stateless, where do you put the state that represents what the user is doing? Okay. Fortunately, we have mostly solved this problem today. A lot of people use an in-memory data grid like Redis. So the cloud function gets a request from this user. Maybe in the API gateway, all the authentication, everything is done, but now you need to pull some data that you don't want in a database, which takes a long time to go and get, but you want to keep it in an in-memory data grid like Redis. So you call from your cloud function into your Redis layer and say, go and get me this user's information so I can do some processing with it, okay? And what's the problem with doing that, though? I said that keeping that user state in memory is bad because it consumes resources. But what's the problem with keeping it in an external Redis layer? Okay, let's just assume the Redis layer costs as much or less than just keeping it in process memory, right? The problem is now what you're doing is you're adding an extra operation, an extra hop over the network to go and get that information, okay? So did Neil Ford give the keynote this morning? Was that him? Yeah, okay. I wasn't here. Anyways, so one of the things that I like that he says is that software architecture is always a series of trade-offs. So what you're trading off in this case is you're trading off additional latency for getting more scalability and that elasticity that you can get with Cloud Functions. So again, the thing I think he's famous for letting software developers and architects know is that software development is a series of trade-offs. i.e., nothing in life comes for free. Okay? So as an architect, you have to be aware that this is the trade-off you're making, and this is what you're giving up for this or for that. All right. Now, in terms of serverless development, again, for those of you who already do this, you probably know this, but we generally tend to try to do things in asynchronous fashion as much as possible. Now, you could have Cloud Function A call Cloud Function B, call Cloud Function C directly, right? Just make a direct call to all three of them. And sometimes you want to make that synchronous call so that the user gets a response much faster. But sometimes you could say, you know what, we actually don't need to get a response so quickly, so let's decouple that a little bit by putting it onto some kind of event bus that Cloud Function B will pick up, and then you put onto another event bus that Cloud Function C will pick up, and then somehow you propagate the response all the way back to the user, okay? But again, when you go from a synchronous to asynchronous style, what is it that you're adding into the system? You're adding latency into the system, right, and overhead. So it may actually it may actually take more CPU resources on the whole to do it, but you decoupled your system so you can scale better and you can be more elastic. All right, so I already talked about this. Events can be almost anything. You can model anything as an event, and this is how you can build this Cloud Function-based application architecture by modeling more on the async using events than the other way around. All right, so when we think of code architecture, what are the two key principles? If you read any of the books on building, any kind of code system, doesn't matter which platform you code on, whether it's Java, JavaScript, Python, Go, whatever. You want high cohesion and loose coupling. Is everyone familiar with these two concepts in terms of software development? Okay, I think most people are familiar with it, so I won't talk too much about this. But basically, high cohesion means that things that are meant to be coupled together are coupled together in the appropriate way, but you also have loose coupling so that when you make a change here, it doesn't affect these other 10 things in your code. Now, when we think about this in terms of Cloud Functions, we want the same thing. We want this loose coupling, which we actually get. Remember, we talked about the example where we have our database operations that we split into 4 different Cloud Functions rather than coupling them into a single Cloud Function. So we're doing loose coupling when we do that. And by naming that specific database operation Cloud Function appropriately, we can also get high cohesion. But if you remember the slide previously where we talked about composition by code as opposed to composition by service, the key difference is that now we're doing composition up here. We're not doing composition down here at the code level. We're doing it way, way, way up top, basically at what I like to call the module or the unit level. All right, so just a few more of these. Now, there are some challenges with this, and I'm going to go on a small rant towards the end of this so that you get a better idea of where the line is between the monolith and the microservices and the Cloud Functions. And actually, I heard something recently. Nate, maybe you know this. Someone said, not majestic monolith, modular monoliths? Right, so there's this term now that a lot of people are moving towards because, in software development, everything is a circle, right? You go, something is cool now, it's not cool, and then it's cool again to do stuff like that. So there's this whole movement right now around modular monoliths, which is large monoliths that can be easily broken apart and still work together, right? It sounds like microservices, but apparently it's not. But one of the biggest challenges around building full applications with Cloud Functions is what's called the Death Star. There was a nice article from Netflix Engineering about 6 or 7 years ago where they showed all the microservices that they had and how they all interconnected. It looked like a giant Death Star, right? So this is what you have to be. This is what you have to watch out for. And to be honest with you, this is still remains one of the key challenges. There are people who've been working on how do we fix this thing? How do we get visibility into all the different cloud functions that we have, so that we can see that, okay, this is what our application looks like, and these are what all the other apps look like, and these are how they're all related, right? Because again, what we're doing is we're doing integration not at the code level down here, where it's easy to understand and manage, and you have strong typing, and you can see like, how things couple together. We're doing it up here. So how do we solve that problem of, okay, we have all these modules, we have these cloud functions or microservices, and you may have hundreds or thousands of them for an application. Right? How do you understand the application? What happens if you change this cloud function over here? What effect does it have on the other cloud functions around it? Okay? So this is one of the key challenges. The other challenge is around startup and footprint for cloud functions. For those of you who are Java or Python devs, you may have heard of this issue. It takes too long for a cloud function to start, right? So this is something that, of course, we have to think about, and depending on the platform you're using, if you're using Go, you don't have to worry about the footprint, because Go compiles down to an executable and uses a small amount of memory, whereas if you're using either a Python or a Java application, it uses a lot more memory. So how much memory are you using if you're using that specific programming platform? And then, of course, there's always discussion around cost control. How much does it cost, right? Where's that line? If we stand up a server, we know we're always paying this every month, and it can take this amount of requests. So if we have this and our cloud function usage goes like this, where's that line where it crosses? It's better to just not use a cloud function, or take that cloud function and put it into something like a microservice where you know exactly how much it's going to cost every month. Okay? All right, so I'm going to talk about this for a few minutes. How many Java devs do we have in the house again, real quick? Okay, so a fair number. So I'm going to go through this very quickly to give you an idea of what's happening to solve some of these problems, or specifically this one problem. Okay, so there's something new that's been invented actually by the company I work for, Azul Systems, called Coordinated Restore Checkpoint. What that does is it allows you to do very, very fast startup of your Java virtual machine. And I have a table that I'm going to show you in a minute to show you exactly how much faster that means. Okay, so there are different options, of course, for starting up JVMs fast. There's AOT with something called GraalVM. But what CRAC in the Java Virtual Machine builds on is called CRIU, or Checkpoint Restore in User Space. Now, this is a Linux kernel level technology that's been around for a little while. So CRIU is not specific for Java. It's just specific for anything running on Linux, where what you can do is you can freeze an application and then start it back up instantly, rather than taking time to do so. Okay? And it is coordinated, so there's some coding that has to be done in your Java app to be able to do this. It comes with an API. And the idea is that you create a checkpoint, and then when you're ready to start that app up again, you say, use this restore point and start the app back up. The best way to explain it is you're at home, you work a full day, or you're in the office, wherever. You finished a full day's work, now you're done. What do? You close the lid on your laptop. Then you go away until tomorrow morning. You open your lid on your laptop, and it's at the exact place at which you closed it. That's exactly what CRAC does. It freezes the JVM with everything inside of it at that specific point, but you can restore to it from a file. Okay? This is something that led by Azul, but it's not proprietary to us. This is something that was contributed into OpenJDK, but we're the first ones to release a commercially supported version of CRAC tech. Okay, and this is how you take a checkpoint. And again, it does require code changes, and you have to close and restore connections when you bring the VM down to take a checkpoint and when you bring it up. Now, as an app developer, how many people are using Spring Boot here, for example? Okay, so that's a lot of folks. So if you're using Spring Boot or Quarkus or Micronaut, you won't have to do any of this coding yourself, right? The folks on the Spring Boot team have told me that they're looking for a beta release of crack support in Spring Boot sometime in November. So that tech is on the way. It's not like a year's away, it's coming soon, okay? But more specifically for the folks here, Amazon already implements crack, right? So they use the same code base that we donated into OpenJDK, and if you're building an application using Java, there's a tick box that you can check that says, I want to use something called Amazon SnapStart. And this SnapStart essentially does exactly what I said. So you say, you give it your jar file, you say, I want to use SnapStart. It builds a special container which has a restore checkpoint for your cloud function inside of it, and then as it needs to scale up the number of concurrent cloud functions on Lambda, it uses that checkpoint so you get instant startup for it. Okay? So if you're wondering, for those of you who are Java devs, this is what it can normally do for, all right, so I mentioned Spring Boot earlier. Let's say a typical Spring Boot app takes about 4 seconds to start. Using Kraken can take 40 milliseconds. So that's 2 orders of magnitude faster startup time. Okay, so this is incredible. And without any of the trade-offs that you have to make if you're using GraalVM. Okay? All right, so the other thing Kraken can be used for is also if you're running in containers as a service or in Kubernetes for that matter. All right, so I want to spend the next 5 to 15 minutes ranting about this specific article. Did anybody read this article from Amazon Prime Video Engineering? Okay. No, but hold on. Did you actually read it, or did you just read the headline and jump to your own conclusions? Right? Because this is what we do today, right? No one bothers to read the article, because who wants to spend 10 minutes reading something? You just read the headline and you draw your own conclusions. That's what the internet was invented for. So. Unfortunately, it's true. Okay? So what happened is when this came out, Twitter was ablaze with this. I'm sorry, what's it called now? It's called X or something? Is that right? Yeah, whatever. So Twitter was, I'm still going to call it Twitter. I don't care what Elon says, right? When this article came out, everyone was like, yeah, I told you, cloud functions are shit. You can't create any apps with them, blah, blah, blah. But if you actually read the article, they go into detail as to why they had to switch from cloud functions to basically monoliths or microservices, okay? And let's see if I have this detailed on a specific slide. Okay, so it was the wrong choice from the very beginning. So how many of you have done this? And be honest, you see some cool new technology in software, you're like, yes, let's start using this, right? And then you go to your team lead, or you are the team lead, right? Or you're the architect, and you say to your team, we're now going to use this. And everyone looks at you like you're crazy, but you end up using it, right? What's it called? Resume-driven development, thank you, right? How many people have done resume-driven development? Oh, come on, there's got to be at least one person in here. You get the point, though, right? So what happened about 6 or 7 years ago when the Amazon, let me get this right, it was the Amazon Prime Video engineering team, they said, let's build everything with cloud functions. We want elasticity, we want scalability, we want to be able to have that low cost and everything like that, right? But it turned out to be the wrong choice from the start in their specific use case. So as an application architect or as an application developer, this is what you have to be aware of. Where's the line between cloud functions are great for this versus, actually, no, we probably just want to build this as a monolith or a microservice or something else, okay? And the answer is on this slide. So the 2 key things that made building this specific portion of Amazon Prime Video a bad choice for cloud functions were that they were doing a large amount of memory-intensive data processing. So that's a double whammy right there. So the first thing is they were using a lot of CPU because the Prime Video team in this specific example, in one of these use cases, was they would take a frame of video data and then process it. Now, if you've ever worked with video data, a 1080p video data frame is approximately 500 to 700 kilobytes, just one frame. Okay, and we're in Spain. What's the TV standard here called? It's called PAL or something, is that right? Yeah, and so I believe PAL has a frame rate of 29.97 frames per second. Okay, you can do the math, right? 500 kilobytes per frame. Each frame, 1 second has approximately 30 frames of data inside of it, et cetera, right? Adds up very quickly. So, point here is they're doing high amounts of memory-intensive data processing, which is something that cloud functions are not good for. And then on top of that, because this is video data, they were shuffling a large amount of data over the internal AWS network. So combine that with the large amount of data transfers, and you have these huge bills for doing very basic things. Something that you could do inside of a monolith or microservice application very cheaply, because you just say, I'm just going to get a XXL instance, ECS instance. I'm going to set up this server, which is the monolith. You keep everything within memory without shuffling it back and forth, and you do processing, and you know exactly how much you're going to pay. So anyways, rant over. Thanks for listening. And we're almost exactly at the end of time. So thank you for coming. I hope you enjoyed it. Follow me on Twitter.
All right, thank you so much for the presentation. Let's start the Q&A session. All right, the first question is, how strong is vendor lock-in with serverless? Once the operating cost threshold is reached, how feasible is to move code to containers without major rewrites?
Okay, so the question is, how do you do cost control around Cloud Functions? Right, so every Cloud Function platform has a maximum number of Cloud Functions you can set. So what that allows you to do is say, the maximum number of this Cloud Function I want is 10 or 100. And once the number of requests exceed the number of available Cloud Functions, what happens is things just end up on an incoming request queue. What that means is that adds latency for your user, or it adds delay for your user until things get processed. Okay? So that's how you do cost control. But again, the trade-off is that if you go over that threshold of what you can handle at that, with that concurrent number of Cloud Functions, is the user has to basically wait for the request to get processed.
Thank you. And what would you not use Cloud Functions for?
I think I already answered that question, so let's skip that one. Okay.
All right, then how to understand the time for migration from FAS before it starts to cost a fortune?
Oh, sorry, say it again.
How to understand the time for migration from FAS before it starts to cost a fortune?
Into what functions?
Sorry?
Into what was the last thing you said?
Before it starts to cost a fortune.
Okay, so the question is around, I think, migrating onto FAS, right? I've seen people break apart a monolith and try to do a FAS with it, and you can be successful with it, especially if you follow the principles that I said, but it does take a lot of time. So people struggle already with taking a large monolith and breaking it down into microservices. So you can imagine breaking it down into even smaller chunks is even more difficult, okay? So what I typically see people do is instead of migrating a monolith to either a microservice or Cloud Function environment platform, what most people do is they spin up their new projects on either microservice or on Cloud Functions. And some people have done it, but it does take a lot of effort. And is it worth it? Sometimes it is, sometimes it isn't. Right? Like Nate was saying, everything in software architecture, the answer is always, it depends.
Thank you. And a lot of problems with serverless function, security, authentication, traceability, debugging, sure to use for confiable architecture? Right.
So that was actually 5 questions in one. So let me start with the first one. Okay. So the first one was on security. Unfortunately, there's no way to sidestep security or application security specifically, especially at the code level. But one of the nice things about Cloud Functions is you don't have to worry about the underlying platforms. You don't have to worry about patches to the operating system or to anything else that's running between your Cloud Function down into the container. Right? I gave that example about the Amazon Snapstart, right? Or Google Cloud Functions. Specifically, what they do is when you give it your code, it actually wraps it into a container, and then it deploys it for you. Right? That's pretty much how all these Cloud Functions platforms work. Even if they're using what you would not consider to be a Docker container, it's some kind of containerization that happens. So a lot of the security stuff is taken away for you from that point of view. And on top of that, typically with Cloud Functions, you use an API gateway on top. So the incoming or top part of the request queue, all the security around that, whether it's what version of TLS you're using, that's already taken care of for you, right? Again, this is part of the reason why Cloud Functions are great. When you use it with the constellation of services, it's the cloud platform's job to go and patch all the services that they have, so you don't have to do that. But in terms of application security, you still have the same issues that you have to be careful about. Like if you're using a library inside of your Cloud Function, you shouldn't be using many, but in case you are, then if that library has a critical bug in it, then it's up to you as the app developer to patch your application with that updated library with a bug feature or a debug fixed, and then you have to deploy it. So what was the second part of the question? I've already forgotten.
Okay, second part of the question. So security of identification, traceability, debugging.
Okay, so let me talk about debugging. Now, there's no doubt that debugging a cloud function is harder than just debugging something that you have as a microservice or a monolith. But the good news is that you can debug everything on your laptop more or less today. So there's all the cloud function providers provide a shim to be able to go and test your cloud function locally, and some of them even provide a way to execute it locally in a limited fashion, of course. You can either mock out the services that it uses in the cloud, whether it's connecting to a database or to an event bus or something. But once you deploy into production, that's where things, of course, get interesting. But if you're already deploying microservices into the cloud, you are familiar with what you have to do to be able to debug a cloud function in the cloud, i.e. it's not easy, right? So typically you want to find the problem locally as much as possible, and that's why you have to write more tests for cloud functions, in my opinion.
Thank you. And can we do DDD using serverless? Oh,
that's a great question. So the question was, can you do domain-driven development using serverless? You know what, I have not thought about that before, because for me, doing domain-driven design, which is more at the code integration level, is the opposite of what you want to do with cloud functions, which is more at the service level. So the short answer is you probably could, but I don't know if you'd want to. Okay?
In your crude microfunction example, isn't creating 4 different functions simply spreading the development complexity to different components, making the overall system more complex if we include deployment and lifecycle considerations?
Okay, so the question is about what's the incidental complexity you get with building cloud functions, or building an application with cloud functions. And as I said before, software architecture is a series of trade-offs. So when you're building in a monolith, what you're doing is you're containing all your complexity down here at the code level, okay? You're integrating at the code level. Even if it's code that you've written, you build classes, you build this object hierarchy, and you do either composition or inheritance to model what you're trying to build. But all that is at the code level, and we have tools, i.e. IDEs, different other things that allow you to examine what you built and understand the system. Now, when you move to cloud functions, how do you do those same things? How do you introspect how your different cloud functions fit together? And the question specifically asked, if you take what would normally be in a few units of code down here and make them into a few units of cloud functions, have you made the complexity better or worse? I would say that the answer is actually the complexity is the same, but of course, the real answer is it depends, right?
Okay, so what fast serverless is good for? What problems does it tackle better than usual solutions?
Okay, so I talked about this. Someone asked already, what is it not good for? And I don't think I've answered what it is good for, so let me take a second to answer that. I love using cloud functions for doing early stage prototyping of a feature or a product, because you can just write code and you say, ship it. You push a button and you ship it. There's none of this DevOps stuff, and you don't have to go and ask this team over here to take this. You don't even have to build, if you don't want to, a CI or CD pipeline for this anymore, because the cloud provider does that for you, right? So when you deploy onto Google Cloud Functions, for example, when you give it your code, whether it's a jar file, a Go executable, or JavaScript NPM, whatever, it literally builds a CI pipeline automatically for you, so you don't even have to do that. Okay, and I think you can hook into parts of that to do very specific things if you want. But in terms of what it's good for, early stage prototyping, things that you know have small units of CPU processing, well, let's say small to medium units of CPU processing, small to medium amounts of memory needed. Also, when you are using lots of different services within your platform provider. So, okay, I need to hook to Kafka, and I need a data store. I may need an in-memory data grid. I may go dip into AI or machine learning. I haven't said that yet. Do I get extra points for saying AI at this conference? I'm just kidding. So when you're using a whole bunch of different services, but you just need to literally glue them together, I think that's the optimum use case for Cloud Functions, right? So you have all this stuff that you can just use off the shelf with all the cloud providers, right? They give you almost everything you need. I think the last time I checked, Amazon had something like 5,000 different cloud services that you could use to build an application, right? So when you just need to glue some of these together and you just need to add a bit of your own custom code, that's like the best case scenario for when you want to use a cloud function. Okay.
As architects, mostly we lead a team. We choose a fast function as a service, then it has to be small. Will we end up with micromanagement?
Okay, that's interesting. You already have a team that's building with Cloud Functions. Will you end up with micromanaging those things? The short answer is probably yes, but I think that if you break down your Cloud Functions to be small enough but still be useful, you don't really have to go and change those Cloud Functions a lot, right? So that gives you a little bit of that loose coupling in some ways. But if you remember previously what I said is one of the key challenges with Cloud Functions is being able to visualize all this stuff so that the human brain can understand it, right? How do you visualize a monolith today? You open your code editor, you drop into the code at the place that you're interested in, and then you hold down the control or whatever button, and you click, 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 and it jumps you from object to object to object or to method, right? So you can say, oh, that's what this does. How do you do that with Cloud Functions? It's a little bit more difficult to do that, right? You have to have architecture diagrams to be able to say, okay, here's my Cloud Functions that do these things, here's my Cloud Functions that do these things. How do they fit together? You have to create diagrams. And of course, creating hand-drawn architecture diagrams for any application, whether it's a monolith or microservice or a Cloud Function, it will always lead to trouble because what happens, you change something in the code, have you changed the architecture diagram that reflects that? Maybe, probably not, right? So those architecture diagrams get out of sync very quickly or they get outdated and they're not useful anymore. So one of the key things with Cloud Functions is you have to document what your Cloud Function does, the interface, and sometimes what's in the Cloud Function to a much more finer level of detail than with just code. Because with code, you can just get the answers by looking at it, as opposed to having to look at a document to figure out what something does. Okay.
And last question.
Yep.
Any tips to test serverless functions properly?
Any tips for?
Test serverless functions properly?
Yeah, so the question is, how do you test Cloud Functions properly? Now, every platform provider gives you some way of testing locally, and there are actually libraries that allow you to go and have mocks for things that a Cloud Function would use, whether it's something like a data store or something like that. And then, for example, if you're using Spring Cloud Functions, this is for the Java people, they have a layer around the underlying Cloud Function, so it provides some abstraction and it fits into the overall way that, for example, the Spring Framework works. If you build in JavaScript, I know there's some folks using JavaScript here, they have a similar thing in the JavaScript universe, which allows you to wrap a Cloud Function inside of a very lightweight JavaScript framework, which then provides testing and other things which are useful to you as a developer. So, okay.
Thank you very much.